everyone to another episode of NerdRx podcast, and I'm your host Barkha. Today we have a behavior technique called fear conditioning, and we have an expert who has done a lot of fear conditioning in his graduate work, and he is my lab mate and also a good friend, Ian Jacobs. Welcome, Ian, to the show.
Hey, Barker, thanks for having me.
It's my pleasure. Thank you so much for giving us your time,
Of
Ian.
course, of course.
So, before we jump into fear conditioning, dreaded fear conditioning, why don't you introduce yourself to our listeners?
So my name's Ian Jacobs. I have a master's degree in experimental psychology, and I'm working on my doctorate right now in behavioral and integrative neuroscience. I'm a sixth year now, graduate student at the University of North Carolina. Um, and so I hope to graduate and be Dr. Jacobs here in just a bit.
Huh. That has a nice ring to it, Dr. Jacobs.
Yeah, I like it too. But yeah, I've been doing fear conditioning for all of my graduate career. I started out in a lab at Appalachian State University where I got my master's, where we were studying more like learning theory type of approach to fear conditioning. And then I moved on to UNC Chapel Hill, where we're looking more at how fear conditioning can be used in the examination of brain circuitry.
Yeah, awesome. So, my first question to you would be what is fear conditioning? And I have seen you do this in the lab, and I honestly don't know how you do it. And what got you interested in it?
Sure. So with fear conditioning, it's a form of classical conditioning. And so with classical conditioning, you have a few pieces that are all in play here. Um, you have first something called an unconditioned stimulus, which is just some sort of event in the environment that occurs or that is detected by the animal, which results in some untrained reflex from that animal. So since we're talking about fear conditioning, right, it might be a loud noise in a movie or something like that that causes you to startle,
Mm-hmm.
right? So when the ghost jumps out or whatever.
Mm-hmm.
Um, Right, so you start with that unconditioned stimulus, and then what you can do is you can take some stimulus that's neutral and does not provoke any sort of response. In the case of fear, in this case, right? So it's like relative to fear, the stimulus doesn't produce a response like something like a puppy dog, which hopefully none of us are terribly afraid of. And so then by pairing the neutral stimulus with the unconditioned stimulus, the puppy dog with the startling ghost, right, over and over and over and over again, um, the idea is that a conditioned response comes to be learned about that neutral stimulus,
Mm-hmm.
where now they will produce a fear response to the neutral stimulus, and now we call it a conditioned stimulus, where it produces
Mm-hmm.
that conditioned response. And so that's kind of the basics of fear conditioning acquisition, where you're actually acquiring those fears. Is you take these neutral stimuli and you pair them with unconditioned stimuli. Um, it can be as few as just one trial is necessary to do it, but typically in experimental settings, they tend to do 3 to 4 presentations of the stimulus pairing before they actually move the animal onto future phases, for
Mm-hmm.
assessments. And so how did I get into it? So I, first heard about this in a learning class in at Appalachian, and um, I just really enjoyed, at the time, in my naive understanding of it, how clean it looked.
Mm-hmm.
Right? So you just pair these two stimuli together, and you watch the conditioned response measurement go up. Right? It's very straightforward in that sense. And then, I got into the lab with the professor for that course, Dr. James Denniston, um, and he took me on and showed me all of the more intricacies of classical conditioning and how you can change all these different experimental parameters to adjust the conditioned responses. And I realized that, viewing it as simple was, of course, like I said, naive.
Yeah.
And I came to appreciate the vast complexities of fear conditioning and just exploring all those different little cracks and crevices of it. It's a lot
Mm-hmm.
of fun.
Wow. Your idea of fun is quite different.
Yeah, maybe fun isn't the best word for it, but it's interesting to learn about
Yeah,
for sure.
for sure. It is definitely interesting to see that. Why would you use fear conditioning in rodents? Like, what are the applications of it?
Sure. So at its core, right, because you're pairing that neutral stimulus with an unconditioned stimulus, what you're actually looking at with classical conditioning is a learning process.
Mm-hmm.
And so you can, anytime you want to assess how an animal is learning, right? Uh, you can use any number of things. You can use operant conditioning, where you're training them to receive some reward, or you can use, classical conditioning, where you're just trying to train a particular type of reflex. And now the benefits of classical conditioning is that it doesn't rely on what's called motivating operations,
Mm-hmm.
for the most part, to actually produce that response. And so, what a motivating operation is, if we roll it back for a second,
Mm-hmm.
um, if you were to present somebody with, a piece of cake after
Mm-hmm.
dinner, right? And, Parker, what's your favorite flavor of cake?
Anything with fruit?
Anything with fruit. Okay, so we have a nice, I'm not going to say fruit cake because it has, holiday
Yeah.
implications, but a cake with nice fruit on it, maybe like a strawberry shortcake, right?
Yeah.
And I feed that to you, and you eat it, and okay, you loved it. And then I feed you it again and again and again and again. And the fervor with which you consumed the strawberry shortcake at the beginning, is, much stronger than you would by your sixth piece of cake. You might
Right.
even straight up refuse the piece of cake,
Mm-hmm.
despite the fact that you love strawberry shortcake so much, right?
Mm-hmm.
And so that's a motivating operation, where
Mm-hmm.
by satiating the person on strawberry shortcake, we've now changed the value that strawberry shortcake has to the individual. Right? So now if we roll this back to an experimental setting, um, if you're talking about how motivating operations can change how rewards function for an animal or a subject, then any changes in the animal's brain, due to disease or any sort of transgenic manipulation of the organism, that changes how they process rewards or how they process motivation to get rewards, is
Mm-hmm.
now going to be affecting your measurements of learning.
Okay.
So to get around that, what we do is we say, okay, let's use fear conditioning. Um, Fear conditioning, and it essentially involves a survival reflex, right? In the wild, if a mouse is out there in the field and it sees something that it should be afraid of,
Mm-hmm.
it produces a freezing response where it's going to try to preserve its own life by limiting its, I guess, detection by
Yep.
other creatures, by predators, right? So it's a survival reflex when it sees something fearful to do that. And survival, I'm sure maybe some people might argue this, but I think that survival is not necessarily a subject to motivating operations in the same way, or at least to the same degree that reward-based learning is.
Mm-hmm.
You're always going to want to survive. So then, since we're separating the learning from reward systems, we can then study these different brain regions and these structures that are involved in associative learning, with a greater fidelity than we could if we use something that was more uh, vulnerable to
Mm-hmm.
environmental manipulations. So that's why you would use fear conditioning over some other type of procedure to measure learning. Um, a second reason to use it is just kind of how uh, clean it can be, right? Like
Mm-hmm.
you're not, when you have something like an operant conditioning paradigm, or an appetitive classical conditioning paradigm, you're again relying on the subject to actually experience and consume that reward or reinforcer.
Mm-hmm.
Whereas in fear conditioning, you're not really giving them an option, right? They receive the fearful stimulus whether or not they want to or not.
Right.
And so you can kind of really force your experimental conditions on these animals, without needing to do much intervention, really.
Mm-hmm.
So yeah, that's why I would use fear conditioning specifically over other types of um, methods for learning.
Okay. Yeah. Thank. That was a very nice and easy to follow
I
explanation.
hope so. I felt like I was rambling there for a bit, but
No, no, no. Thank you so much for that. So, would you mind taking us through the steps involved here? Like, how would you go on to set up this experiment, and how long does it usually take for you to run this entire experiment?
sure. So with fear conditioning, the setup you need to do is you need to have. I'm going to talk specifically about uh, fear conditioning involving foot shocks.
Okay.
So there are other methods which I think I'll talk about later, uh,
Hmm.
that you can use to assess fear learning.
Okay.
But my main experience is using foot shocks in operant conditioning chambers. So I'm going to come at it from
Hmm.
that perspective. So
Okay.
all you need first is you need a operant conditioning box. You can The original ones were built by B.F. Skinner, but you can just buy it for any retailer that would sell these, and you have a electric grid floor that is down in the bottom of it. And so what this grid floor does is it passes an electric current, a very mild and not painful
Mm-hmm.
current through the floor to the animal. And it requires the animal, of course, to be on the floor, which for rodents is not always a given, but for the most part, they tend to hang out on the floor.
Yeah.
Um, and so when I say it's delivering a mild foot shock, I don't know if Barker, you've ever had like those joke pins that
Oh,
you
yeah.
press the button and it shocks you a little
Yes.
bit, and it kind of
Yes.
just feels like a vibration.
Mm-hmm.
So that same sort of uh, feeling is what we're going for when we try to put these electric shocks through the
Okay.
ground, right? Not a painful one, but just something you'd rather not press that pen cap again, right? Like
Mm-hmm.
I just don't want to experience that again. Um,
Yep.
so you have these animals in the box, and you have them with the electric foot shocks going on, and then you get to choose how you want to present stimuli to them, right? What neutral stimulus do you want to present to these animals?
Mm-hmm.
One way to do it is to simply use the place that the animal is in as the neutral stimulus, right? This
Okay.
operant conditioning box maybe produces some hesitation at first while they explore it, but there's nothing terribly frightening about being in a box. In fact, most rodents tend to enjoy being in dark boxes.
Mm-hmm.
It's pretty safe there. And so you then would give them the foot shock in this setting, and they learn now that the neutral stimulus of the context is now being paired with this foot shock, and so now you have contextual fear conditioning. And so that's going
Mm-hmm.
to engage a particular set of brain regions if you use that one. What you can also do is something called cued fear conditioning, where you're going to present what's called a discrete cue. A cue that has a beginning and an end, something like a 60-second tone or flashing light, for example, that
Mm-hmm.
you can turn on and off. You then present that stimulus before the actual foot shock happens, and then the idea is that you will then pair that discrete cue with the foot shock, causing cued fear conditioning to occur, and the conditioned response would happen to the now the discrete cue. And again, that's going to involve a different subset of associated learning circuitry. So you
Mm-hmm.
can kind of use these different methods to parse that out. Then what you can do, right, is I mentioned that there's different modalities of these stimuli that you can use. You can use visual, auditory, um, something that's kind of difficult to do well, but would honestly be best for rodents in
Yeah.
particular, is to use their primary sense and to try to use olfactory cues, right, odors,
Mm-hmm.
to as the neutral stimuli in order to make sure that they detect and are able to see those and
Mm-hmm.
experience those stimuli. And so then what you can do from there, right, is that's just the process to acquire the fear. What you would do is you would then pair those. Again, it depends on your experiment that you're trying to run. You could pair them one time or multiple times, and then you would say that you have acquired a conditioned response. So in this case now, what you're doing is you're going to then extinguish that conditioned response if you wanted to take this a little bit further. So, whereas in what we call acquisition of that conditioned response, you are pairing the neutral stimulus with the unconditioned stimulus. In extinction, you're just presenting that neutral stimulus, or what's now a conditioned stimulus,
Mm-hmm.
alone by itself without any unconditioned stimuli present. And so the idea then is that over time, they would learn. It's a form of new learning, right? It's not just an erasure of old learning, but it's a
Mm-hmm.
new learning that stimulus, which they thought was a good predictor of this unconditioned stimulus happening, is now no longer a good predictor, and so it can be more or less ignored, and the conditioned response to that conditioned stimulus will decrease over time, and that process is called extinction.
Okay.
So now you have a fear that you've acquired and treated, and so now the question becomes, what else can you do with this? Well, one of the my favorite activities to then do is to study relapse after this, and this has a lot of implications for drug relapse. When we think about
Mm-hmm.
relapse and drug addiction, and what you do is you can then manipulate the different context, what sort of stimuli the subject experiences, and you can get different types of relapse. I can talk about those a bit if you want, but I think we're kind of
Yeah.
getting into a longer subject. But briefly, okay.
Yeah.
So the first type of relapse is just called reacquisition, right? This one's kind of
Mm-hmm.
unsurprising and boring. Reacquisition is just where you after you provide an extinction treatment and the animal is treated for their fear, you then present the neutral stimulus or the conditioned stimulus together with the unconditioned stimulus again, and then you test them to see if they're afraid of the conditioned stimulus. Spoilers,
Hmm.
they will be.
Yeah.
Um, then you have spontaneous recovery, which is just the idea that um, over time, the animal will spontaneously recover the conditioned response. And this happens over the course of just 24 hours, right? So between extinction sessions, you can actually view the spontaneous recovery occurring in your animals. It's just where their conditioned response will be higher at the very beginning of the session than it was on the last trial of the session before.
Hmm.
That's spontaneous recovery. You have reinstatement, which is kind of like reacquisition, where you're just going to present the unconditioned stimulus again by itself, right? So you're not pairing the neutral stimulus with the conditioned stimulus with this unconditioned stimulus. You're just presenting the unconditioned stimulus alone. And the idea
Yeah.
is that then when you present the animal with the conditioned stimulus at test, following that reinstatement treatment, they should now have the conditioned response to the conditioned stimulus return, despite never having been trained with that again, like they were in a reacquisition. And finally, you have uh, renewal, which is a contextual form of relapse. And so this one kind of requires us to back up a little bit. Um,
Yeah.
so this is why this one got to be a little bit of a long one. In acquisition, right, it's known that the first learned information tends to generalize the best. What I mean by that is that if you learn that fire is hot and it will burn you if you touch it, right, you're going to apply that learning to everywhere that you see fire. Right?
Yeah.
Every situation you see fire, it's safe to assume it's going to burn you, and that makes real good sense to us. Um,
Hmm.
Now, cases where it doesn't make quite as much sense is, let's say, a neighbor dog, bit you when you were a kid, and now you're afraid of all dogs.
Yeah.
That's a little reasonable, but maybe a little bit of overkill as far as
Yeah.
your responses are concerned. So that's what we mean by the first learned information tends to generalize the most, right?
Hmm.
Um, so then, when you provide an extinction treatment, right? So you provide this acquisition treatment or this acquisition process in one context, right? If you then switch context and put the animal in a different place and you provide them treatment for that fear in that new place, the learning about that arrangement, right, about that stimuli, that extinction, becomes specific to that place.
Hmm.
So then when relapse occurs, uh, if you simply move the animal outside of that extinction context, that place where they received extinction, you will see a return of the conditioned response. Um,
Mm.
you haven't presented them with the fearful unconditioned stimulus again. You
Right.
haven't paired anything else again. You simply move them outside of the extinction context. And because information learned in acquisition, that first learned information, generalizes the most readily, whatever context you put them in, they're going to pretend like they're afraid, or I mean, actually be afraid, right, of that stimulus.
Hmm.
Um, and so that's how relapse renewal works. It's just that change
Wow.
outside of the extinction context is going to cause renewal. Now, what's kind of interesting about that, just to kind of continue this little
Yeah.
spitballing,
Yeah.
it doesn't just have to be physical places, right? You can also use what are called interoceptive contexts. So a place that you're in, right, the room that you're in right now, is something called an exteroceptive context. It is external to the individual. Interoceptive contexts are things that are internal to the individual, whether or not the animal is under the influence of any drugs, right? Have you hopped that mouse up on cocaine or not?
Hmm.
Um, is it hungry or not, right? Like, have you fed it in the past 24 hours, or is it starving? And now that's a different interoceptive state than when it was
Yeah.
hungry. So if you were to train a fear when they were hungry, treat them when they were satiated on food, when their bellies were full, and then return them to a hungry state, they should show renewal. So it's
Hmm.
all kind of interesting like that, that you can do both physical places as well as states of the animal acting as relapse triggers.
Hmm. There are so many variables to this.
Oh,
Like,
yes.
I can imagine so many things going wrong here.
Yes. Yeah. The kind of crucial thing about all of this is to do everything the same for every animal all the time forever. And
Wow.
that's a big ask for humans.
Yeah, for sure.
Sorry, one last thing. You
And
asked me how long it
yeah,
would take. Um,
yes.
so for acquisition, that typically takes a day, right? You're just going to provide that. Even if you're doing multiple treatments or sorry, multiple trials or just a single trial, it's only 1 day. Extinction typically takes longer. In rats, we got good extinction after a week when we used 4 foot shocks, right?
Mm-hmm.
Um, the length of extinction is going to depend on a number of different variables, including how intense your unconditioned stimuli is, how intense your neutral stimuli are, the biological disposition of the animal. Tons of different stuff are going to affect the length of
Mm-hmm.
extinction. Um, and then yeah, and then so extinction takes roughly a week, we'll say, and
Okay.
then the relapse test is just a day after extinction. So you can
Mm-hmm.
just, if you provide a reinstatement treatment, right, you would just spend 1 day to, or reinstatement or reacquisition, you would spend 1 day to present them with that either neutral and unconditioned stimulus or just the unconditioned stimulus alone, and then the next day you would test them, or in the case of something like renewal or spontaneous recovery, you just simply have to place them back in the box the next day after extinction, and you should see the relapse occur there.
Mm-hmm. Okay. I didn't know you work with rats as well. So, in your experience, are rats better or mice?
Oh, rats, 100% rats. Um, Mice, I actually learned about recently in my dissertation. Um, so mice largely come in inbred strains, right? Uh,
Yeah.
and depending on which strain you use, you may or may not see all of these different things that I've been talking about. Um,
Wow.
I'll talk about it a little bit later, but kind of, before I read these experiments, I kind of thought this was a more universal um,
Yeah.
uh, feature, I guess, of life.
Mm-hmm.
But it does, because the mechanisms on the biological level and the cellular level are preserved everywhere from aplysia up to humans, which
Mm-hmm.
is what Candel won the Nobel Prize for way
Right.
back in the day. And so to hear that, oh, it just depends on the particular mouse strain that you're using whether or not you'll actually get, for instance, renewal effects, um, was a bit surprising to me. Um,
Mm.
in general, too, rats just tend to connect things in their environment more readily than mice. Mice tend to take longer and need more obvious stimuli than rats.
Mm-hmm.
Um, so yeah, I would use rats whenever you can, but a lot of the neuroscientists out there are shaking their heads because they understand that a lot of their transgenic strains are only available in mice.
In mice. Yep. 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 So, there is a high chance that you plan and do everything, you set this experiment, and it's not going to work because of your mouse
Yep,
line.
could be, could be.
Amazing.
Um, and what's interesting about it too is that unless you actually do the experiment, you won't know because they'll do, for instance, DBA mice
Hmm.
won't show renewal. Um,
Oh.
so they acquire the same, they extinguish the same as sort of the lab standard mouse, the C57 Black 6J mouse, right? Um,
Hmm.
they'll perform the same as those mice, and then when you get to the renewal test, they're just meh, and they just don't they just don't do it. So it's kind of this
Wow.
thing that I thought was more ubiquitous than it truly seems to be.
Wow. Yeah, that is one, I would say, disadvantages of behavior techniques in general, as compared to, all the biochemistry techniques we do. It's like, it's going to
Yeah,
work, it. But with animal, it's always so
it
tricky.
is. It is.
Um, so thank you so much for giving us that overview
Of
of
course.
all the steps. Are there any alternative techniques to fear conditioning in order to assess the same things you're going for in fear
Right.
conditioning?
So I'm gonna take this as saying like alternatives within fear conditioning first. Like, so
Okay.
I talked about my main method is to use the foot shocks, right? That's kind of what I was
Yeah.
trained on and everything. Um, but one of the modern sort of approaches to this fear conditioning stuff is actually to use a something called the looming predator task.
Hmm.
And so what this does is rather than relying on foot shocks to actually provide the unconditioned stimuli, it um, sort of tricks the mice and the rats into thinking there is a predator looming above their heads. And so what they do is they have a transparent box that they put these animals in, and then in one corner of the box is a like a little hut that they can go into. It's really cute, but they have like this little tent basically that they can escape into and get out of the way, right?
Hmm.
And so what they do is they have a screen positioned on the roof of this transparent box. So from the animal's perspective, if it were to look up, it would see the screen.
Mm-hmm.
And they take a stimulus, a little circle, and they can sweep that circle. It's like a black circle across the screen, or they can make the circle go to the center of the screen and enlarge to fill the entire screen.
Wow.
And the idea is that this is supposed to mimic a swoop by an approaching predator.
Yeah.
So yeah, like the birds in the sky, right?
Mm-hmm.
It's circling around the field that the mouse is in. The mouse is
Right.
freezing at this point to not be detected, right? Because the bird's
Mm-hmm.
vision is based on movement, as we learned from like Jurassic Park. But so it freezes in that circumstance. But when they have the looming predator where it's going to enlarge that circle and that shadow basically is going to get bigger and bigger and bigger, it's supposed to be like the predator is coming right at them. And so the idea is that they'll perform a different type of fear response, a flight response, where they're going to
Hmm.
flee to safety. And so this is very interesting
Yeah.
because, first of all, you're not actually doing anything to the mouse.
Mm-hmm.
So in terms of, whether or not the ethics of providing foot shocks to animals, you can just kind of skirt around all those because you're literally not doing anything to them. So it's kind of nice in that way,
Yeah.
right? It's good to reduce the pain and the discomfort that animals experience.
Mm-hmm.
Um, but what it's also revealed is that there are sex differences in how these animals are going to perform their fear responses.
Mm-hmm.
Um, I think for the most part, uh, males tend to do more freezing behaviors. I might have this backwards, but I think males tend to do more freezing behaviors and females tend to do more flight behaviors. And so when you're looking at something like using foot shocks and you're just measuring freezing behaviors, you might not be appreciating the true complexity of sex differences that are
Mm-hmm.
there for you. Another task that they use is something called the RoboGator task, and this one's interesting just because it's I don't know if you ever watch videos on it. It's pretty funny. It's
Mm-hmm.
kind of a corny procedure, I think, but it's nonetheless pretty cool. So what they do in this one is they have um, basically a little robotic car
Mm-hmm.
on one side of a hallway, and they put the mouse on the other side of the hallway.
Mm-hmm.
And the idea is that the mouse, ventures out into the hallway, and it sees that there's this thing on the other end of the chamber, and it should be a little bit wary of it. But they bait food right in front of the RoboGator.
Mm-hmm.
And so they're, oh, this mouse is hungry and there's some food right there, but I have to go next to the monster. And so they'll have the mouse go out and approach it, and then as the mouse gets past a certain threshold, they'll have the gator, the RoboGator,
Yeah.
drive forward and use like these lightly grasping claws basically to, yeah, gotcha. And it's a little interesting
Yeah.
because you can do things that would affect fear conditioning circuitry, like lesions to the amygdala or the
Yeah.
hippocampus, and they'll affect how the animal will approach these this sort of conundrum, where if you were to lesion the amygdala, for instance, those animals just do not care.
Oh wow.
They will waltz right up to that RoboGator, take the chomp, and carry on with their day. And so it's kind of wild to see how they would interact in a more realistic predator situation. Because as I mentioned in the beginning, right, the whole point of using fear conditioning in the first place is to tap into this survival reflex, right?
Correct.
To get the animal to do defensive things to protect its own life. And so if you're using things that are more similar to the way the animal would behave in a natural environment, right?
Mm-hmm.
Using these looming predators or these physical predators, um, I feel like that's a bit more ecologically valid than
Mm-hmm.
saying, I'm just going to use foot shocks.
Mm-hmm. Well, when you were explaining this RoboGator, the only image in front of my eyes was from The Shining.
The Shining? Like from the statues?
The hallway with the twins and
Yes, it's exactly like that, dude. Yes, that is perfect. Oh man.
oh
Yes,
my
the
god.
twins are just sitting down at the end of the hall, and yet there's a nice, tasty burger.
Yeah.
Decisions,
Yeah.
decisions.
oh my
Uh,
god.
so, but outside of fear conditioning, right? If you wanted to study associative learning circuitry, um, if you want to study the specific circuitry that's involved in what's called conditioned aversive emotional responses, you would need to study fear conditioning.
Mm-hmm.
Um, there's not really a lot ethically more that you could do to the animal beyond that,
Correct.
nor that you would really want to. But if you're just interested in reflexes, I mean, there's tons of reflexes. Whole classical conditioning got its start in salivation, right? Pavlov
Mm-hmm.
had his dogs and he rang the bell, or it's actually a metronome, fun fact.
Mm-hmm.
But he played this metronome and the dog salivated, and bam, reflex, classical conditioning.
Yeah.
So you can study that circuitry. But what you're going to be involving then, if you're adding any sort of appetitive stimulus, is you're going to start involving things like the nucleus accumbens or the lateral habenula to do these sort of feeding behaviors and to
Mm-hmm.
monitor rewards like that. And so that gets, I mean, we talked about the motivating operations, a little bit more tricky to do like that. But if you're trying to study reflexes and don't want to use fear, that's one way to do it.
Right.
Another way is to use drugs, right? So I think at our university, Dr. Don Lyle, he does experiments where he conditions immune responses that result from heroin treatments.
Wow.
So he gives the animal heroin in a particular context. The animal then, of course, uh, has its immune response, which is to depress the immune system uh, when the heroin's on board. And then when he puts them back in that context later, right, he sees that despite the fact that they haven't received heroin, they will see this depressed immune response in their animals. And so you can, study reflexes in that way as well. And that also is a type of learning that is worth studying. So there's other ways that you can get around it.
Mm-hmm. Okay. So what would you say is the most difficult step? I mean, the step that involves a lot of troubleshooting in this entire experiment.
Hmm. Well, all right. So if you're just trying to acquire the fear, right? If you're
Mm-hmm.
just trying to see if there's acquisition differences between your groups, the hardest part is the initial setup, where you are trying to titrate the exact shock that you need to use.
Okay.
So one thing I've learned over my many years of doing this and my many purchases from, uh, you know, uh, supply companies is
Mm-hmm.
that the equipment's not always the same.
Yeah.
There could be a surprising amount of variation in the actual output of some of these machines. So, just to get technical for a moment, the way that the shock is produced is it has a box on the outside of the enclosures that produces the shock and runs it to the floors, and you can adjust the level of that shock, the intensity of that shock. And what I'm saying is that when that unit reads that this is for instance, zero point 0.7 milliamp shock, right? Is it actually zero point 0.7 milliamps?
Mm-hmm.
Maybe. Sometimes it's pretty good, but there's always a few of them whenever you do a purchase that need a little bit more, right? Maybe you need to set it to 0.73 to actually get that zero point 0.7 milliamp shock. And
Okay.
why that's important is because, as we mentioned, the intensity of your stimuli
Yeah.
determine the speed and the robustness of the learning that occurs.
Mm-hmm.
So if you have differences in that, and then you see differences in your groups, well, is it just due to the fact that you shocked one a lot harder than you shocked the other one?
Mm-hmm.
Um, then, what I found was with, we are using a transgenic line in our lab.
Yeah.
Um, Depending on the particular mouse strain that you use, you'll have to titrate different levels of shock to try to produce a condition response that is comparable uh, um, to your other studies or to controls if you're using wild types, or if there are, if you're actually trying to measure if there are differences in acquisition, right?
Mm-hmm.
You need to know how much those types of intensities of unconditioned stimuli are playing into that.
Right.
Beyond that, if you're trying to do extinction, I think the hardest part is just, well, determining how long to do the extinction treatment for.
Right.
So if you have a system like in rats, one of the benefits of using rats is that you can use something called suppression ratios to determine the animal's performance. So you train the animal to perform some operant task. The idea is that when the animal is afraid, it's going to freeze, and so when it's freezing, it is not performing the operant task. So you're asking, right, how much did the presentation of this fearful stimulus suppress the operant activity? And that gives you an idea of the degree of fear that the animal's getting. And so that's really, really easy to calculate, right? If you're doing something like lever presses, you can calculate that on the spot uh, you know,
Yeah.
in the actual program itself. And so you get an idea of exactly how well your animals are doing.
Mm-hmm.
In our lab, we didn't do that because, again, mice are really, really dumb. I cannot stress that enough how dumb a mouse is. Um, we thought that the length of time it would take to make them perform an operant response, and in our tap mice, a basic nose poke for food response took our animals 10 months to train.
Wow.
Um, so just to put it in perspective of how bad they are at this stuff, that's how long that took to just train a simple behavior. So we weren't about to do that for this study. So what we did was we used a visual identifier for when they were freezing, of like when they were ceasing all their movement, right? And so for
Right.
that one, let's say you have 32 subjects and you put them in a box for 60 minutes, you have 32 hours of footage
Yeah.
to go through in a day
Mm-hmm.
to determine whether or not your animals are at a level of extinction that you can then provide a relapse test to them, right?
Wow.
So that's obviously not possible unless you have like a
Yeah.
team of full-time undergraduates, and I mean like 8 hours a day, going through these videos.
Yeah.
Um, so it in that part, it's a little bit hard to figure out what length of time you need for your subjects to actually
Correct.
extinguish, because unless you're using something like a suppression ratio, or they do have alternatives where they have computers that can code videos for you,
Mm-hmm.
um, they require very specific equipment, um, but determining that length of time can be very difficult. The final thing that I think is the most difficult is determining your and like getting your actual experiment room correct
Yeah.
and appropriate. So, you know, as you've mentioned, there are a lot of things that are going on in this experiment. Um, there's a lot of different variables that can impact whether or not an animal freezes or not. Um, anyone who's had a pet knows that, especially like a cat, right? Like any sort of unexpected stimulus, like a cucumber on the ground or a loud noise in the corner, right, is going to make them freak out and
Mm-hmm.
perform this fear response to something that's completely irrelevant.
Mm-hmm.
Well, what if that happens while you're in the middle of your experiment, right? What if you're trying to code how afraid this animal is, and maybe a someone drops something outside and
Yeah.
it makes like a beaker crashes down and breaks, right? Like,
Yeah.
okay, well now you've just ruined an entire batch of animals because they um, experience this extraneous variable. So
Wow.
limiting those factors as much as possible, having white noise on in your rooms to make sure that the outside is more or less quiet.
Mm-hmm.
Controlling the environment outside. And I know for our labs at UNC, we sadly have our the doors to our laboratories um, accessible to the undergraduate population, which
Yeah.
you know they're cool and all, but they also are noisy. In our
Yeah.
lab in particular, we have a classroom that lets out every hour
Yes.
right next to our labs. So if you're
Yes.
doing this experiment and some undergraduate comes along talking about their night real loud and they laugh real loud, the animal's going to freeze up to that.
Yeah.
And you don't know if it's due to your procedure or if it's due to the actual extraneous
Yeah.
variable there. So I think controlling your environment is extremely difficult with this.
Mm-hmm. Yeah. Now I have started putting up a sign whenever I run behavior
Yes.
outside
Yes.
the door that please do not enter. Just keep quiet.
And I think when people read it, they think like, "Oh, I'm being quiet." No, 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 no. We mean
Yeah.
absolutely silent,
Yeah.
please. Um,
Yeah.
yeah. So some laboratories are better about that. I know at Wilmington, UNC Wilmington, they have a whole wing of their psychology building dedicated to the animals and the
Wow.
yeah. So they got it real nice over there.
Mm-hmm. Wow. That's great. So my next question is this easy to learn? Like in terms of a scientist like me, if I want to learn fear conditioning, is it easy or it has a huge learning curve?
So I think performing the experiments is exceptionally easy.
Okay.
Um, it's a really great project for undergraduates to do because, first of all, undergraduates are very motivated to, at least, if you choose them right, are very motivated to perform well. And
Yeah.
so they're kind of uncomfortable um, with laboratory work, and they're always worried that they're doing something wrong.
Yeah.
And so they're very careful about how they do things. And you tell them straight up, you need to do this the same every single time.
Yeah.
And all it involves for them is picking a rat or a mouse up, putting it in a box, and running a program. The rest is
Mm-hmm.
history, right? They leave the room. They don't have to do anything about it. The science gets done.
Mm-hmm.
Where it becomes difficult is in setting up the experiments. If you can have somebody provide you with a program for these boxes that will, present your stimuli in the way that you want to the animals, it can be pretty easy to set up on that end. Writing the programs is a bit difficult and it requires a bit of skill. Troubleshooting your data is also pretty difficult. Um, when things work right and as expected, it's easy, right? But when things go wrong, and as I just said, like, in my dissertation that I'm working on right now, uh, uh, my animals didn't show the renewal effect, and so
Mm-hmm.
I had to go looking like, why the heck aren't they showing the renewal effect? And trying all this troubleshooting stuff, only to find out, at the end of this whole story that there's just some mouse strains that just don't show it, and so it's
Mm.
common in inbred and transgenic mouse lines for them to just sort of lose the ability to do this.
Mm-hmm.
Um, so that's that, right? So troubleshooting that takes a long time, and knowing where to look for those things can be difficult. But I think it's mostly. I know it sounds complicated on the beginning, like to learn all the
Yeah.
different pieces. But once you have those pieces down, I think it's incredibly easy to learn. And when you do one experiment, once you got that one experiment down, all you have to do is change one variable, and bam, you have a whole new experiment with a whole new set of data and a whole
Mm.
new publication. Um,
Right.
I think it's a pretty robust, easy to learn
Yeah,
test.
when you explain it that way, I'm like, oh wow, yeah, it is really cool.
Yeah, right, right. But for anyone doing this in a maybe non laboratory setting, like if you're doing this in an educational setting, I think if you can get past the whole giving foot shocks to animals thing, a classical conditioning experiment is quick, it's easy to perform, and it gives the students very clear data in a way that they can feel like they actually performed an animal experiment in a very short period of time. So I think it's great for education.
Right. So, what are the advantages and disadvantages of fear conditioning?
Okay, so advantages, right? You're free of any motivating operations. We talked
Right.
about that before. I also think that uh, in terms of fear conditioning, it's kind of like there are cases where the animal cannot experience the stimuli that you're giving to them, but in the most cases, you can be pretty sure that all of your animals have received the same treatment, right? Um, Another advantage is just again how quick it is. Uh,
Mm-hmm.
you can have an experiment done in just over a week, which is
Mm.
a great turnaround for experiment, especially considering that for our population of mice, at least, the turnaround for an operant conditioning experiment, where we're also studying learning in that case, was 10 months.
Mm.
So definitely, I changed over to doing fear conditioning for my dissertation for just that reason. Um,
Right.
I also think that the the conclusions you draw from it, if you're careful not to ascribe, too much personification to the mouse, right? If you just purely talk in the behavioral terms, are hard to argue with, because you have very clear numbers that show whether or not the animal was freezing or not in a particular circumstance, and that's
Mm-hmm.
just the numbers. Like you can't say like, oh well, were you just counting something that you shouldn't have counted, right? Did you not have a good operational definition of your behaviors? Well, no, we did. It was freezing, and here's the video if you want to watch for yourself. I just
Mm-hmm.
think it's very hard to argue with the findings from fear conditioning. As far
Okay.
as disadvantages go, the first is it's extremely awkward to talk about with people.
Yeah.
I think when people hear foot shocks, they imagine like a
Yeah.
an execution chamber,
Yeah.
um, and it's just not that, and it's
Yeah.
hard to get people over that hurdle. Um, I think too, like I mentioned, there are sex differences in at least freezing behaviors that make the inclusion of female subjects. I'm not going to say troublesome because most of the time you'll get no differences between your sexes. Um, but when you do, you have to ask, was I using the correct assessment here or not?
Mm-hmm.
Another disadvantage is, hmm, I guess just how vulnerable it is to environmental influences. When you're talking
Yeah.
about something like a reflex, um, you're not allowing the animal to, I said not to personify them, but think about it too much, right? Like they just are performing a response based on the data they have in front of them, or the stimulus that they have in front of them, and any sort of alteration to that stimulus, the way that's detected, could influence their performance, or any sort of extraneous variable that is influencing whether or not they're afraid on a given trial, could be a, uh, a wrench in the plan, so to speak.
Mm-hmm.
For instance, let's say you are in an extinction treatment and you're training them to not be afraid to atone, um, and then on day 6, right, a beaker breaks outside, and suddenly this loud crash happens while just after you
Oh
presented
my
your
God.
tone. All of a sudden, your animals are afraid again. They're freezing to the tone, but for a different reason, right?
Mm-hmm.
And so, your experiment just kind of got ruined by one thing. That's
Yeah.
actually the final thing I'll mention too about the disadvantages is these animals are kind of one-trick ponies, that you use. So when you do an operant conditioning study, you can train them to press a lever for sugar pellets,
Mm-hmm.
poke their nose for peanut butter, um, not poke their nose for sunflower seeds, right? Like whatever you want to do, you can train them to do all these different things, and retrain them, and it's all kind of okay. With a classical conditioning experiment, once you provide a stimulus arrangement, right, that first learned information is going to generalize very readily to all these different contexts and procedures. So if you were to bring them into a new experiment, the learning from that old experiment is going to heavily influence the speed at which your animals learn about the new information.
Wow.
It'll also influence if you're trying to do like something like renewal or something like that, and you've used those stimuli before,
Mm-hmm.
you might not actually get good acquisition to see that renewal effect later on because you've just done all this stuff in the past. Um, and so for that reason, it's kind of it uses a lot of animals, which I know can be distasteful to some. Um, and like especially if you're talking about some of these transgenic or optogenetic ready animals, it can get very expensive to run your
Mm-hmm.
experiment and then have on day 7 someone break a beaker and have the whole thing be ruined, and you can't go back. You
Yeah.
can't you can't take that back. You can't retrain them for a few days. It's done. Um, and so that's kind of a weak part of it too.
So you cannot even use this animal for a complete new experiment, like, for example, T maze or a novel object.
Well, like you probably could, right? You probably could use them for something like that. But if you were to try to use them for an operant conditioning experiment in the same
Mm-hmm.
operant chambers that they just got the foot shock in,
Yeah.
you can see the problem there, right? Like
Yeah.
they'd be afraid, and it would slow the actual acquisition of the
Mm-hmm.
operant. If that's something you're measuring, if it's not something you're measuring, then maybe it'd be okay.
Mm.
But uh, I don't know, man. I think when you provide such a strong experience where you're
Yeah.
threatening in the animal's mind the survival of the animal, I think that messes with them a bit.
Yeah.
And then if it's something like the RoboGator task, right? Like you're putting them in a maze-like situation and then attacking them.
Yeah.
So they might not choose to do the maze in the future.
Yeah. Yeah. That's always going to be the shining task for me.
Yeah, the RoboGator one. I love to show students the amygdala one. It's a good video.
Yeah. So, what are the costs associated in setting fear conditioning? Is it expensive, or any lab with some access can set this up?
I think relative to the rest of science, it's pretty okay. Relative
Okay.
to everyday purchases, God no, it's so expensive. I think our last quote for getting, what did we get? Did we get 16 boxes? I think we got 16. No, 8 boxes. I think 8 boxes was $32,000.
What?
Yeah, so it was, and that's with the whole shock setup and everything, and that was not even kitted out in the ways that we could have kitted them out, and it's without having the equipment to do computer-based analysis of the videos. So
Mm-hmm.
it gets very expensive in that sense to do this. But once you have it set up, there's no reagents you need to buy. There's no
Right.
antibodies to keep track of and to store. There is simply just animals to keep. And if your
Yeah.
university or your uh, business has a good breeding program, I mean, it's essentially just the cost of chow to keep this going.
Yeah. So it's just like the first setup
Yeah, the
cost.
initial setup is a little high, but you can also build it yourself. My mentor at Appalachian, uh, you know, I think he set up his in the I'm going to feel like if he ever hears this, he might get mad at me. I think he set it up in the 80s or like in the 90s, but that
Uh-huh.
might make him too old. I'm not sure. Um, they didn't have all this like newfangled technology with the whole boxes that produce the shock now. So he set up a neon sign transformer to produce the shock
Hmm.
for him, and like daisy chained all of his boxes together in a way that tried to evenly distribute the shock to each of them. So I mean, you can
Wow.
just if you have some engineering know-how, you can just make these things no problem. It's literally just a
Hmm.
box with a grid floor on it. Um, so yeah, I think it can be depending on how. But okay, so actually, here's something that I should say. I don't think you should do that. I don't think you should set up your own materials. One of the things I'd like to see in science, and especially in behavioral research, is a standardization of all these methods and techniques.
Right.
Like you mentioned, the T maze and the there's also different types of arenas that people use, and a
Mm-hmm.
lot of the times people will just build them themselves because it's
Mm-hmm.
just a box, and like why would I pay $10,000 to get a box?
Mm-hmm.
Um, but I think that it's worth standardizing um, the equipment that we're using because these environmental variables can be so impactful on the performance of
Right.
our animals that when we're trying to compare between studies, when I'm trying to compare my renewal data to your renewal data, I'd like to know that we were
Mm-hmm.
using the same equipment.
Correct.
So I think that I actually wouldn't say, I would say, buy it from a reputable source and try as much as you
Mm-hmm.
can to standardize what you're doing.
Right. Okay. And now we come to my favorite question. Is there any fun fact about fear
Okay,
conditioning?
so I actually sort of spoiled it already, but I couldn't avoid it. Um, the fun fact I have, and maybe put an asterisk next to it because I am learning more each day about this. But Candel did this experiment in aplysia back in I think it was 2009, which won the Nobel Prize, where he discovered the circuitry within the aplysia for producing the fear response. When you pair that neutral stimulus and that um, unconditioned stimulus together. Um, and just a real quick, what the aplysia experiment was is aplysia have a gill withdrawal reflex. So they're an aquatic mollusk, and they have a gill on the top of their body, where if you touch the gill, or if you touch things around the gill, it'll retract and pull into the
Mm-hmm.
creature. And so, what you can do then is you can pair a touch of they call it a siphon, which is a structure near the gill. You can
Mm-hmm.
pair a touch to the siphon, which won't produce a huge response, with a not a foot shock, a tail shock, um, towards the back of the mollusk. And over time, what you'll see is a strengthening of the gill withdrawal reflex to just the stimulation of its siphon. This is what Kendall did in his experiment, and he followed the whole circuitry involved in these three particular neurons that were coding for this entire learning process.
Mm-hmm.
And then when they scaled it up and they looked at more complex creatures and more complex creatures, they found that the basic, I mean, there's more of them, but the basic
Mm-hmm.
structure of these neurons, which are responsible for this process, are preserved across a number of different species, which warranted the Nobel Prize because it is quite the
Yeah.
discovery. So when
Mm-hmm.
you're talking about something like fear conditioning and you're studying something like fear conditioning, and you say, well, you're doing it in mice or you're doing it in rats, how does this apply to humans? Bam, directly. It's the same circuitry. So I just think
Mm-hmm.
that's a kind of fun fact that, like, when you
Yeah.
see a mollusk learning about tail shocks, it's the same thing that's going on in your brain as it is in theirs. So I think that's a little interesting.
Isn't that
I think
fascinating?
so.
Oh my God.
That's what's kept me in love with this stuff. Is just
Yeah.
learning, like, I think as I've learned more and done more animal research, I've really begun to appreciate the cognitive abilities of these animals. I'm not trying to
Mm-hmm.
personify them and say that they're fully on the level of humans, but I think people going around saying, for instance, like dogs don't have memories, don't really
What?
understand what's going on in the dog's brain.
Yeah.
Because yeah, they definitely definitely do.
Oh my God.
Anyway,
Well, to wrap things up, my last question to you is, can you suggest any article or a protocol about fear conditioning that I can link in the description?
sure, I can. So it's going to require you to have like at least a little bit of background in
Hmm.
this stuff, but
Yeah.
it's a Boughton 2002 paper. Let me see if I can pull it up. The paper is called Context, Ambiguity, and Unlearning: Sources of Relapse After Behavioral Extinction. So that doesn't sound too interesting, but this is actually a really good seminal paper that I think introduces people to a lot of the stuff that happens after acquisition. So the
Hmm.
acquisition part's pretty straightforward, but one of the contemporary issues at the time this was written was whether or not the extinction that occurs, right, that weakening of the conditioned response uh, during extinction, is at a type of unlearning where the
Hmm.
information that was learned in acquisition is destroyed and no longer present in the animal's brain. And this paper here kind of goes through a series of experiments, and it's sort of a review of the experiments that tell us that extinction is not a process of unlearning. It's actually a new type of learning that occurs, and then goes through all of its evidence for why that's the case, and then wraps up with just some like, how would you actually use this information in real life?
Hmm.
So I think it's a really interesting, cool article to just introduce people to these topics and sort of get an idea of
Hmm.
how the words are used.
Well, Ian, that was an amazing episode. I have a new appreciation about fear conditioning after listening to you. And thank you so much for your time to explain what fear conditioning is to
Of
us.
course. Thank you so much for having me on here. This has been a lot of fun.
Yeah, it is. It is. Thank you so much, Ian. And listeners, I will catch you next week on another episode. And in meanwhile, if you have any suggestions or if you would like to come on the podcast and discuss something with me, please email me at barkha@nerdrxpodcast.com. And remember, it's good to be a nerd. Bye.